we have graphed piecewise functions before, but never quite like this. We haven't really done anything with absolute value graphs thrown in and square root graphs. Shouldn't be a big deal though. We know we're going to have 3 different pieces, and you should know what each one looks like. So for example, on this one, we know that it's going to be a V shape and it's going to open up. So we're going to have something that looks like this. Now, and what we did in Algebra 2, we talked about having arrows, like where the arrow would be. This points to the left. I'm going to have an arrow on this side, and because we're not including the 0, I'm going to end up with some kind of an open circle on this side. For the next piece, I'm going to have, again, it's a V shape. Now, keep in mind, we don't know how much of the V we're going to have. We could have a V, or we could just have a line segment piece. But whatever we do, we're going to have endpoints on both sides. However, I think this one's not going to be a V because we're just going to have the straight line piece of it. This we know is a square root curve, so we know we're going to have something that looks like this. So knowing about the parent graph is going to help, and since it's not including the 2, we're going to have an open circle on this piece. So what we don't know is how these 3 pieces are going to be joined together, if they'll connect, or if we'll have a discontinuity. So I'm going to start with the first piece. Now if I use the parent graph, absolute value of x, I see this is shifted 2 to the left. So I'm going to go ahead and plot my point. Now remember, this is only going to be for values that are less than 0 of x, so we're going to stop when we get to 0. So I can see I'm okay going this direction. Now there's no stretching or anything, so this part going towards the left is just going to look like this, except it would be a straight line there. This side, for the V, we would go this direction, but then it's going to stop right here at the 0, because remember, we're only defining this when x is less than 0. So I get this part of the V. Then for my next piece, I have an absolute value. So it's the parent graph, and it's shifted down 2. And that's okay, because remember, we want x goes from 0 to 2. So I'm going to go ahead and put a solid dot on this piece. And I know my curve, or my absolute value, it's not stretched, so it's going to be going in this direction. And it stops. I have to stop when I get to x equals 2, that's where I'm at. So I'm going to put a dot on this piece. And now I'm ready. So I only had the straight line, that little straight section. So now I have the absolute value, or I'm sorry, the square root curve. So this is the parent graph shifted 2 to the right and up 2. So the parent graph starts at 0, 0. We're going to go to the right 2 and up 2. And that's where my locator point's going to be. Remember, we said it would be an open circle. And since it's not stretched, I can just follow the parent graph, which if you remember, you can look back at your parent function graphs. We had over 1 and up 1, over 4 and up 2, because the square root of 4 is 2. And so I end up with this curve. So this is actually my graph of my piecewise function. Now let's talk about the domain and range. For the domain, we used every possible value of x, because we go from negative infinity to 0, and even though the 0 is not included here, it's included down here. So we continue on. So for the domain, it's actually all real numbers. You could write it like this, or we could write it from negative infinity to infinity in interval notation. And for the range, now if we look here, we don't have anything below negative 2, and then as we move up, okay, well, it's covered here, so there's not a problem there. And as we move here, now you might look at these open circles and say, well, we're not supposed to include 2, but the 2 for the height is included over here. So actually, we're going to say y is greater than or equal to negative 2, and in interval notation, that would look like this, from negative 2 to infinity. So that would be my domain and range. Now I'm going to show you how to do this on the calculator, and it's going to take a little time, but I think you'll find that it's worth it. So the first thing I'm going to do, and when we do a piecewise function, we have to kind of be careful when we graph this. We're going to have to put this in parentheses, and I'm going to graph the absolute value of x plus 2. There's a shortcut if you go alpha F2, absolute value of x plus 2. And then I'm going to close the parenthesis. And now I'm going to put divide by, and I'll explain that part later. And then in parentheses, we're going to, we want x is less than 0. So I type in the x. Now the less than symbols are all under this test, so which is the math key that you have to hit second, test. and we want less than, so we want number 5, 0, in the parenthesis. Down to the next one. Now we're going to type in, I need a parenthesis again, and we want the absolute value, so I'm going to have alpha f2 of x, and then the minus 2 goes outside of the absolute value. Close the parenthesis. Got to do divide by again. Now this one's even different because I have to do this in 2 pieces. I can say 0 is less than, so you're going to go alpha test, and we want less than or equal to, which is number 6, and type in an x. And I can't do a compound inequality just by typing in the symbol. I actually have to use the word and. To find the word and, you're going to go second, test, and over to logic. And you'll see and. And now I have to do the second part of that, which is x is less than or equal to, so second, test, less than or equal to, again, is number 6, 2, and close the parenthesis. Down to the next piece. We have, again, we need parenthesis, the square root of x minus 2, and then plus 2. Make sure you exited the square root function. Close the parenthesis. Divide by parenthesis. X is greater than 2. So x, second test, find greater than, close the parenthesis. That's a lot of work, wasn't it? So now if we type in, I'm going to exit this, so second quit, and I'm going to do zoom 6 for a standard viewing window. And there we go. So that's how you can use your calculator to graph a piecewise function. Now notice it doesn't show you where the closed-in parts are and where the open circles are, but you can get a sketch of the graph. Now I want you to try this. This is a multiple choice problem. So I want you to pause the video and take a look at the clues. Pay attention to these symbols and where you would expect to find an open circle and where you would expect to find a filled in dot, and see if you can figure out which piece would be, which piecewise function would be accurate. Okay, so hopefully you've had a chance to think about this. Let me show you what I would do. I focused on this middle piece first, and I know that this is the parent graph shifted down too. And so when I looked at the center, I saw those are all accurately drawn as far as where they've placed the portion of the parabola. But notice these symbols. These both are less than or equal to, so it has the equal to part. So that tells me I should have endpoints filled in for this piece of the parabola. So I know the answer is not C, and I know the answer is not B. So I've narrowed it down. Then I looked at this one here, and I know that this is the parent function of the square root graph, and it's been shifted to the right too. So if you notice on this one shifted up instead, so this one's wrong, but this one did correctly shift it to the right too. So this is the correct answer, and then you can kind of verify this one was the parabola shifted to the left one, and that is exactly what it is. So that's how you can do a multiple choice problem. You don't actually have to graph the whole thing. You can just use those clues to determine which answer is correct.